Welcome to a refresher lesson for rational exponents and radical functions, graphing. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. In order to talk about graphing different types of functions, starting today with our rational exponent and root functions, we need to take a moment to think about graphing transformations. Now, if you're not familiar with this, or if you've forgotten about this, let me just give you a brief overview, which starts with the fact that for most types of functions. Doesn't matter what type of function it is. It can be square root functions like we're talking about today. It can be polynomial functions. It can be rational functions. It can be trigonometric functions. Any kind of function has what we call a parent function to it. And that is the simplest form of that function. And then we can insert numbers in different ways within that function. And each of those numbers has an effect on what the graph is going to look like. So the overall form of what that function will look like is what this represents. Okay, once all of the numbers are inserted in their different places, this is what it would look like overall in general for any kind of function. And you can see here that basically there are four different numbers that get inserted in. There is an a value out here, which is getting multiplied to the front of the function. There is a b value, which is also getting multiplied, but it is happening inside of the function. Then we have an h value, which is getting subtracted on the inside of the function. And finally, we have a k value here, which gets added to the outside of the function. So two values that are getting multiplied, two values being added or subtracted, and it just depends on whether it's happening outside of the function or inside of the function as to what effect they will have. Now, those effects can be either what we call a rigid transformation or a non-rigid transformation. A rigid transformation is going to change something about the graph, but does not change its shape. So it might move the graph, it might reflect the graph, but the shape does not change. A non-rigid transformation means we're actually changing the shape of it. We're going to stretch it, we're going to shrink it, the shape will actually change. Okay, and so you can see here, h and k are the numbers that are responsible for moving the graph around, what we call a translation. A and B have a couple of different roles to them. If A or B is negative, that means we're going to have a reflection that happens through one of the axes. If A or B is something other than 1, then that means we'll have that stretch or shrink happening. And notice with the dilation numbers, we're talking about the absolute value of A or the absolute value of B, because we don't care about what the sign is. If it's positive or negative, that is what tells us whether we have a reflection or not. So we're really just interested in what the number is. If that number is bigger than 1, it's going to be a stretch if we're going vertically, or a shrink if we're working horizontally. If it is a fraction between 0 and 1, then vertically we get the shrink and horizontally we get the stretch. So if you need to, go ahead and pause the video for just a moment and take a good look at this table before we proceed into actually graphing. All right, so let's start with the square root function. I'm going to show you the process that I recommend for doing these kinds of graphs and transformations. I think it's pretty straightforward. It works with any type of function. And so I think it will help you to organize your thoughts and your work. So I usually start with identifying what is my parent function. In other words, what is the family of functions we're dealing with, and what is the simplest version of that? In this case, we're dealing with square root functions, and the simplest version is f of x equal to the square root of x. And so then I'm going to think about, well, what does that graph look like? That's an easy one to graph. What does that look like? And so we have points like 0, 0, and 1, 1, and 4, 2. And so we know we have this curve that kind of looks like half of a U on its side. Now, when you're just beginning with this kind of graphing, it's not a bad idea to actually go ahead and graph the parent function first and then make the transformations you need to. Eventually, as you get more confident with doing the graphing, you can just think about what the parent function looks like and then make your changes from there. Okay, but that's the first step. Identify the parent function and what that graph would look like. Then we're going to identify those values, A, B, H, and K. So remember, A is the number that is multiplied out in front of the function, in this case, the square root. Okay, that's our A value. Our B value is going to be whatever's getting multiplied in the inside, so inside of our square root. The H value is what is being subtracted on the inside of the square root. And our K value is what gets added on the outside of our square root. So our A is going to be -1. Our B, since there isn't any coefficient on X, we're not multiplying by anything other than just a 1. For our H, we have 2. Remember, the negative is part of the format of the structure of the function. So it's not part of what the H value is. So H is just 2. And then K on the outside, that gets added. And so the fact that it's -1 means that K must have been a -1. So you identify those values, and then you identify what kind of transformation happens based on that. So if A is -1, that means we'll have a reflection through the x-axis. B, since that's just 1, there's no effect on our graph. The H being 2 means we're going to move our graph 2 units to the right, since 2 is positive. And then K being -1 means we are also going to move 1 unit, but down, since the 1 is negative. Now, when you actually go to start doing these transformations on your parent function, I highly recommend you go in alphabetical order. You work with the A and the B values first to do any reflections or any stretching or shrinking, and then work with H and K to move your graph around. So let's do that. I'm going to start with my A value of -1, which means I'm going to reflect all of the points on my original parent function through the x-axis. Well, since 0, 0 is on the x-axis, the reflection remains on the x-axis. So 0, 0 stays 0, 0. My point of 1, 1 here, if that gets reflected through the x-axis, it now becomes the point 1, -1. My point 4, 2 getting reflected becomes the point 4, -2. And so just from the reflection part, my graph would now look like this. That half of a U shape is getting flipped over the x-axis. Now I'm going to deal with H and K and move that blue graph around. So every point on the blue graph is now going to move 2 units to the right and 1 unit down. So my 0, 0 point, 2 units to the right, 1 unit down. I have a new point right there. 1, -1 now, 2 units to the right, 1 unit down, gives me a point right there. And that 4, -2 is going to go 2 units to the right, 1 unit down, and I get a point right there. And so now I connect those new points into that half a U-shaped curve. And the green graph now is the final answer to what g of x would look like. Okay. Let's take a look at another example. So this time we have h of x equal to the square root of 2x plus 6. So we are still dealing with a parent function that is the square root of x function. So we know it's still going to look like this. Okay, that's our starting place. Now, when I go to identify A, B, H, and K, I have to be a little bit careful in this case because in the structure that we were looking at, we saw that our function needed to be A times F, and then it was B times X minus H in parentheses plus K. So this on the inside of my function needs to be factored before I can identify what H is. So I need to rewrite my square root of 2x plus 3 to be the square root of 2 times x. I'm sorry, that was 2x plus 6. Got ahead of myself. And now it's 2 factored out, and x plus 3 is what will be in the parentheses. Now it matches the form that we need to be in. Now I can identify what my values are. So my A is what's outside. I'm not multiplying by anything on the outside, so that's just a 1. My B is what I'm multiplying by on the inside, so that's 2. My H is going to be a -3 because, again, the format, the structure is minus. Excuse me. So H must have been a -3 in order for me to end up with x plus 3. And the K value is going to be a 0 because I'm not adding or subtracting anything on the outside. So the effects that this will have on my orange graph is that this is going to be a horizontal shrink because it is a value that the absolute value is bigger than 1. And the 3 is going to move my graph 3 units to the left this time because of it being negative. Okay. So again, I'm going to start with my B value, and I'm going to deal with this horizontal shrink first. Now, if you go back to the table, in the column where it shows you what happens to each point, you see that for every point on the original graph, if I have a B value that is bigger than 1, that is going to divide my x coordinate by that B value. So if I start with the point 0, 0, the 0 in my x divided by the 2 for my B is still 0, 0. So that one doesn't change. I still have this point at 0, 0. Then I take the point 1, 1. I divide my x coordinate by the 2, and I end up with the point 1/2, 1. So that's going to move my point right there. Then I take the point 4, 2, divide the 4 for my x coordinate by 2, and I end up with 2, 2 as a point. So that's going to put that right there. And if you want to think out a little bit more to make sure you've got a good idea what the shape is, you could just think about other points like 9, 3, even though it's not on our original orange graph based on the space that we have. We still know 9, 3 would be a point on the parent function. And if I took that 9 and divided it by 2, I would get 4.5, 3 as another possible point. Okay, so this is what my graph would look like after the horizontal shrink. And you can kind of see that if you imagined the orange graph being something flexible and then somebody grabbing it on the left and the right and squeezing it, you would imagine that the graph would kind of bulge up and down from that. And that's what we're seeing with that blue graph. Now we're going to take each of those points on the blue graph and we are going to move them 3 units to the left. So 0, 0, 3 units to the left puts me right here at negative 3, 0. I now have 1/2, 1. If I go 3 units to the left, I'm at negative 2.5, 1. My 2, 2 point, 3 to the left ends up at negative 1, 2. And my 4.5, 3 point, if I go 3 units to the left, ends up at 1.5, 3. And so now I can connect those points into a nice curve. And this is my h of x graph. So let's take a look at a cube root function. So I would go through the same process. First, I want to identify my parent function, which in this case is going to be the simplest version of a cube root function, so cube root of x. And the cube root of x is going to have points like 0, 0, 1, 1, 8, 2, negative 1, 1, and negative 8, excuse me, negative 1, negative 1, negative 8, negative 2. Okay. Now, in order to be able to get enough points so that I can really see what the shape of my graph should be, I'm going to need to change my scale. So we're going to go with 10 and negative 10 here on my x-axis so that my scale is 2. But I'm going to keep my y-axis as 5 and negative 5. Okay, now remember this because we're going to need to be really careful about how we graph things with this new scale. Okay, but my points then are going to be at 0, 0. And so now 1, 1 means I'm only going half over and up 1. And then 8, 2 means I'm here to 8 and up 2. And then for negative 1, 1, I'd be here. And for negative 8, negative 2, sorry, got that in the wrong spot. I'm going to be right here. Okay, so the general form of a regular cube root of x graph looks something like this. Okay, that's the parent function that we're working with. Now let's identify our a, b, h, and k values. So the a is what we multiply by on the outside, so that's going to be our 2. The b is what we multiply by on the inside, but since x does not have a coefficient, that means b is just 1. Okay. For our h, that's what we add or subtract on the inside. And so the h is going to be the 3, because again, the minus is part of the format. And then finally, we have the K value, which is what we add on the outside. And so my K value is going to be 1. Okay, so with my B value being a 1, there's no transformation there. A equal to 2 means I have absolute value bigger than 1, so we're going to have a vertical stretch. And then H being 3 means we're going to move 3 units to the right since it's positive. And K equals 1 means we will be moving 1 unit up since it's positive. Okay, so let's deal with the vertical stretch first. Okay, so again, if we take our points, I've got the point 0, 0. On a vertical stretch, that means we take every y coordinate and multiply it by the a value, which is 2 in this case. So with 0, 0, I'm still left with 0, 0. That point stays. If I have the point 1, 1, multiplying the y coordinate by 2 gives me 1, 2. So now I'm going to be over here 1 and up 2 units right there. Okay. Then I have 8, 2. Multiply the y coordinate by 2, and I end up with 8, 4. So at 8, I'm going up to 4 now. Then I have -1, -1, which will become -1, -2. Puts a point there. And -8, -2 will become -8, -4, which puts a point right there. So you can see how this graph right now, just from doing the vertical stretch, kind of looks like someone grabbed the orange graph from the top and the bottom and pulled. Okay, that's what a vertical stretch would be. Now, we want to take that blue graph and we want to do our translations. We want to move it around. So each point on the blue graph is now going to go 3 units to the right and 1 unit up. Now again, be careful, our scale moving left and right is every line is 2 units. So from 0, if I want to go 3 units to the right, I'm going to there. And then 1 unit up would put me right there. For this blue one, 3 units to the right, 1 up is right there. Here I go 3 units to the right, 1 up, right there. This point will go 3 units to the right, 1 up. And this point will go 3 units to the right and 1 up. Okay, and now we can sketch our graph. With its vertical stretch and with its translation to get something that looks like this. This is our G of X graph. Okay, let's take a look at one more example. Here we have the cube root of 3 minus x, which looks a little bit like the format that we want, but it's not quite what we want because we usually want, well, we do want x to be first and the number to be second inside of the function. So we need to think about how do we rewrite this to meet the format? And we would have to rewrite it as a -1x plus 3. And if that's the case, then that means we have a b value of -1 and we need to factor that out. So we'd have a -1 on the outside, and then we'd have x minus 3 on the inside. This is the form we want to use to identify our a, b, h, and k values. So again, we start with the fact that we have a parent function of f of x equals cubed root x. And again, I'm going to use my scale of 2's on the x-axis and 1's on the y-axis. Okay, so 0, 0, 1, 2, excuse me, 1, 1, 8, 2, -1, -1, -8, -2. Okay, so here's the graph that we're starting with. Now, for A, B, H, and K, there is no number out in front, so A is just 1. My B value is this -1 number. The H value is the 3 that's being added on the inside, and the K is 0 because we have nothing on the outside being added. So here we're going to have a reflection through the y-axis, since it's the B that's negative, and then our H is going to move 3 units to the right. Okay? So if we reflect, that means every point the x coordinate becomes negative. So 0, 0 stays the same, but then my 1, 1 point becomes -1, 1. So that reflects there. My 8, 2 point becomes -8, 2. So it reflects to this position. My -1, -1 point becomes +1, -1. So it reflects over here. And then my -8, -2 becomes +8, -2 and reflects over here. So now I have a reflection through the y-axis that looks like this. Okay, mirror image. Now we take every point on that blue graph and we move it 3 units to the right. And again, remember, my left-right is in a scale of 2. So 3 units to the right here is going to give me a point right there. 3 units here gives me a point there. Oh, to the right, sorry. I'm going to the left. Let me change that. Helps if I know my right from my left. All right, 3 units to the right. We're going to go from this point to here. From this point, we go here. From this point, we go here. 0, 0 becomes 3, 0. This point ends up here. And this point will end up here. There we go. And now you can draw your curve. Right? And that is our h of x graph. All right. I hope you found this helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math page on YouTube. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.